Hi guys! So in this video, we will be going over covalent Lewis structures and how to draw them. You're going to need a periodic table and you may want a calculator if you are as bad at math as I am, simple mental math as I am. So let's get started. Okay, so for covalent substances, they share their electrons. So we draw their Lewis structures a little differently than we do with ionic. So in ionic, the electrons are transferred. So we actually drew that transfer of electrons. Here they're shared, so we're going to draw them shared. So here's what happens. All right, so step one is going to be add up the total number of valence electrons in the particle. Now, if it has a charge, we either need to add or take away. So if it's positive, we'll take away electrons because positive means we've lost electrons. If it's negative, we'll add electrons because it means we've added electrons. Okay. Then we need to determine which atom is going to be the central atom. So who's going to be our center atom? It's kind of two ways. So typically it's going to be the one present in the fewest number. So if you only have one of one, it's probably going to be your central atom. Or it'll be the one with the lowest electronegativity. Hydrogen should never be your central atom, and carbon, if there is carbon, carbon is always the central atom. So hydrogen is never your central atom. Carbon is always the central atom. And you can determine which one is the least electronegative because it's going to be the one furthest to the left and furthest down. So the further down and the further to the left you are, the less electronegative you are. Okay, then we're going to draw our bonds between atoms. So you're just going to bond them all to the central atom. And we just draw bonds as like a dash, kind of. So we're going to draw these bonds between it. And each one of those bonds represents 2 electrons. Struggle in there. Okay. And then we'll fill the octets of all the outside atoms. So fill the octets of everything outside. So an octet means that everybody wants to have 8 total electrons. So you'll fill them up to have that full 8 electrons. There are a few exceptions to the octet rule, though. Hydrogen only holds 2 electrons, beryllium only holds 4, and boron can hold 6 or 8. But boron, most of the time, only holds 6 electrons. It's pretty rare that you see it hold more than that. All right, after you've done that, we're going to place any leftovers on the central atom in pairs. So it'll look like just 2 little dots like that, and that'll be our lone pair of electrons on our central atom. And then after that, once we've done that, we're just checking. So we want to make sure that our central atom has at least an octet. It could have up to 12 pairs of electrons if you have extra, or 6 electrons, 12 total, but 6 pairs. If it does not have an octet, it will resonate to satisfy the central atom. If the particle is an ion, be sure to place it in square brackets and put the charge outside the bracket. And so sometimes also if our central atom doesn't have enough, we have to create a double or a triple bond. So if our central atom doesn't have enough, we create a double or triple bond where they share more electrons than we started with. Okay, there's a lot of rules here. They're not as complicated as they seem. So let's get started with our first one. So our first one is water. And water's formula is H2O. Okay, so step 1 is we want to calculate all of our valence electrons. So we have hydrogen. We have 2 hydrogens, and each hydrogen has 1 valence electron since they're in group 1 on our periodic table. Then we have oxygen. We have 1 oxygen, and each oxygen, it's in group 16, so each oxygen has 6 valence electrons. And then we're going to add those up to get our total number of valence electrons. So 2 times 1 plus 1 times 6, 2 plus 6, gives me a total of 8 valence electrons to work with. Okay, so we have 8 valence electrons here. So that's step 1. Step 2, determine our central atom. We have hydrogen and oxygen. So hydrogen can never be the central atom, so this one is nice and easy because of our 2 options, only oxygen is able to be the central atom. So oxygen will be our central atom, and then we're just going to bond our hydrogens to it. So I'll put 1 hydrogen over there and 1 hydrogen over there. All right, so now we've bonded, and so each bond holds 2 electrons. So that means we've used 2, 4 electrons. We have 8 total to work with. So I'm going to go ahead and fill the octets of my outer atoms. They're both hydrogen, and so hydrogen is full with only 2 electrons, and it has that in that bond right there because those are shared between them. So hydrogen has them and oxygen has them. So they're shared between them. So hydrogens, both of them are full with their 2 electrons. So I'm going to go ahead and put the rest of them on my oxygen in pairs. So I'm going to put 2 up here and 2 down here. All right, so now what we want to do is we want to check that everyone has at least an octet or is full. So we'll start with our hydrogen. All right, our hydrogen right there, it's got those on the left, our left hydrogen has those 2 electrons shared, so it is full because hydrogen only needs 2 electrons. Same with our right hydrogen, it's got those 2 electrons. And then we'll check our oxygen. So our oxygen right here has 2, 4, 6, 8. So our oxygen is full. So everybody has the correct number of electrons. So this would be our correct Lewis structure right here for water. Okay, let's try our next one. So our next one is nitrogen gas. So if you remember, nitrogen is part of Brinkelhoff. Bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. So those are our elements that always come in 2s when they're by themselves. So that means nitrogen right here is going to come, and its formula is going to be in 2 because it's part of Brinkelhoff. It's a diatomic. Okay, so step 1, determine how many valence electrons. So I have 2 nitrogens. It's in group 15. So that means it has 5 valence electrons, which gives me a total of 10 valence electrons to work with in my Lewis structure. So we've determined the number of valence electrons. So now step 2 is to determine our central atom. Well, I literally only have nitrogen, and there's only 2 of them. So anytime you have 2, there's not really a central atom because there's only 2. So I'm just going to bond my 2 nitrogens together. All right, and so in this bond right here, we've used 2 electrons. So that means we still have 8 more to give. All right, so I'm going to start filling up the outer octets of both of them. So then we've used 2, 4, 6, 8, and then 10. All right, so now then I want to check that everybody has at least an octet. So we're going to start with our nitrogen on our left. It's got 2, 4, 6, 8. So that nitrogen is good. It's full. It's got its octet. So then now we'll check the nitrogen on the right. It's got 2, 4. Okay, so that nitrogen is not full because it only has 4 electrons and it needs to have, or it should have 8. All right, so what we're going to do, all right, is we are going to steal a pair from the other nitrogen and then create a double bond. So then we can check there. So now that we have a double bond, they are sharing 4 electrons between them. And this one still only has, but that other nitrogen still only has 6. So we'll steal 1 more pair of electrons and put it in between them and create a triple bond between those nitrogens. All right, now then if we check, we have 6 electrons shared right there, 2 on that nitrogen. So that nitrogen has 8. And then again, 6 shared right there, 2 on that nitrogen. So that nitrogen has 8. So everybody is stable and has the full octet that they need. Okay, let's try ammonium. So ammonium is one of your polyatomic ions, and ammonium is NH4 with a positive 1 charge. So NH4 with a positive 1 charge. Okay, step 1, determine your number of valence electrons. So in ammonium, I have nitrogen and hydrogen. I have 1 nitrogen, and it has 5 valence electrons because nitrogen is in group 15. And I have 4 hydrogens, and each hydrogen has 1 valence electron because it is in group 1. So I'm going to add those together, and that gives me 9 electrons. But I have this positive 1 charge, so that means because I have positive, it means I've lost 1 electron. So I'm going to subtract 1, giving me a total of 8 valence electrons to work with. Okay, so we're going to determine our central atom. We have nitrogen and hydrogen. So once again, hydrogen can never be our central atom, so our central atom is going to be nitrogen. So I'll put nitrogen in the center, and then we're just going to go ahead and bond the 4 hydrogens to our nitrogen. Okay, so at this point we've used 2, 4, 6, 8 electrons. So we've used all of our electrons. So now we just want to check, does everybody have that full octet? So we'll start with our hydrogens. Looks like each of our hydrogen is sharing a pair, so that, remember, those pairs count as 2. So each hydrogen has its full 2 electrons that it wants. And then for our nitrogen, we have 2, 4, 6, 8 electrons. So our nitrogen has its full octet as well. So that one is good, but we do have one more step since we do have an ion here. So because this is an ion, we need to put it in square brackets and place its charge outside. So ammonium has a +1 charge, so we'll put it in square brackets with a +1. Okay, let's try our next one. So this time we have sulfate, which once again is one of our polyatomic ions. So sulfate is SO4, the -2 charge. All right, let's determine our valence electrons. So we have sulfur, and we have 1 sulfur, and it has 6 valence electrons. And we have oxygen. We have 4 oxygens, also with 6 valence electrons, because both of those are in group 16. So 6 plus 24 gives me a total of 30 valence electrons, but I've got that -2. So -2 tells me that I have added 2 electrons. So I'm going to add 2 to that, and I get a total of 32 valence electrons to work with. Okay, so now we need to determine our central atom. So we have sulfur and oxygen. So sulfur is further down on the periodic table. It's right below oxygen on the periodic table. So it is going to be less electronegative. So that will be our central atom. We also only have 1 sulfur versus 4 oxygen. So it makes sense that that one's going to be our central atom since we have less of them in our compound. Okay, so we'll put sulfur in our central atom and bond 4 oxygens to it. Okay, we've bonded 4 oxygens, so that means we've used 8 total electrons. We still have 32 minus 8, what is that, 24? So we still have 24 left to use. So we're going to fill out our outer octets here. So we have 2, 4, 6, and that oxygen has a full octet. 8, 10, 12, and then that one has a full octet. 14, 16, 18, that one has a full octet now. 20, 22, 24. All right, so we've used, and that one has a full octet. So we've used all of our electrons. Let's check to make sure everybody has at least an octet. So all of our oxygens look the same. So we have 2, 4, 6, 8 on all of our oxygens. And then our sulfur has 2, 4, 6, 8 as well. So our sulfur has that full octet. So everybody is full, but once again, this is an ion. So that means that we need to put it into the square brackets. I didn't leave myself quite enough space to do that. And then put the charge outside of it. So it would look like that. Okay, let's do ethane. So ethane is going to be slightly different since it is a carbon chain. So anytime we have multiple carbons, we're going to chain them together. And I'll show you what that means. So step 1, we are going to determine our valence electrons. So I have carbon. I have 2 carbons, each with 4 valence electrons in them. because it's in group 14. And then I have hydrogen. And I have 6 hydrogens, each with 1 valence electron. So I have 8 plus 6, add them together, gives me a total of 14 valence electrons to work with. Okay, so carbon is always my central atom, but here I have 2 carbons. So when I have multiple carbons, what I'm going to do is I'm going to bond those carbons together and then put everything around them. Okay, so we have 3 hydrogens, so or 6 hydrogens, so 3 for each carbon. So we're gonna go ahead and bond them on there. And then we'll check all of our octets. So hydrogens only need 2. So each hydrogen has 1 bond, so each hydrogen should be good. And now let's check our carbons. So our first carbon has 2, 4, 6, 8. So that one should be full, have that full octet there. And our second carbon has 2, 4, 6, 8. So that one has a full octet as well. And so it looks good. So again, if you have multiple carbons, just create a carbon chain and then put your bonds around that. All right. Okay. Oxygen difluoride. So we have oxygen, and then difluoride would be F2. All right. So we need to figure out our valence electrons. So we have oxygen, we have 1 oxygen, and it's in group 16, so it's going to have 6 valence electrons. Then we have 2 fluorines, it's in group 17, so it's going to have 7 valence electrons. So add those up, so 6 plus 14 gives us a total of 20 valence electrons to work with. All right. So figure out our central atom. So we have oxygen and fluorine. Oxygen is going to be less electronegative than fluorine. So we're going to put oxygen in the center and then bond those 2 fluorines to either side. All right. Now that I've bonded those fluorines to either side, I've used 4 electrons. I still have 16 more to use, so I'm going to fill my outer octets. So each fluorine has 2 right now, so it could use 6 more. So we have 2, 4, 6. That fluorine is good. 12, 14. Okay, and then we have 16. All right, so all of our valence electrons, all of our octets of our outer atoms are full. So we're going to go ahead and put our remaining. So we have 4 more, so we'll put them on our oxygen. Now we've used all 20 of our electrons. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So let's check all of our octets. All right, so I'm going to start with my left fluorine. 2, 4, 6, 8. That one's good. 2, 4, 6, 8. That one's good. Now we'll check our oxygen. 2, 4, 6, 8. So everybody has a full octet, so everybody would be stable. So this would be our correct Lewis structure here. Okay. All right, guys. So this one is butane, and we just practiced doing a carbon chain just a minute ago. So I'll give you guys the formula. So butane, but is 4. So that means we have C4, and then H would be 2 times 4 plus 2. So 2 times 4 is 8 plus 2 would be 10. So C4H10. So I want you guys to pause the video and try and go ahead and fill out the Lewis structure for butane. And then whenever you're ready, restart the video and we'll go over it. Okay, so this one is, So the answer to this one is right here. So we have 4 carbons chained together with hydrogen surrounding each of them to give them enough bonds. All right. Okay, guys. Let's work the next one. So the next one we have is CO2. So carbon dioxide, so CO2. All right. So I have a carbon, 1 carbon, and that carbon will have 4 valence electrons. And I have oxygen. I have 2 oxygens, and each oxygen has 6 valence electrons because of where they are on the periodic table. Okay, So carbon has those 4 valence electrons, 1 carbon, 4 valence electrons. Oxygen has 6 with 2 oxygens. So that gives us a total of 4 plus 12, so 16 valence electrons to work with. All right, so since we have carbon, it's going to be our central atom. And then there are 2 oxygens, so I'm going to go ahead and bond an oxygen on either side. I've used a total of 4 valence electrons here. Still have 12 more to go, so I'm going to fill my outside octets. So 2, 4, 6. That gives us a total of 8 on that oxygen. 2, 4, 6 gives us a total of 8 on that oxygen, and we've used all of our electrons. But you'll notice that right now, my carbon does not have a full octet. My carbon only has 4 valence electrons. So what are we going to do? Anytime we've run out of electrons and there's no more, we're going to make a double bond. So I'm going to steal a pair from that oxygen and make a double bond over there. Gives my oxygen still has 8 because I have essentially 2, 4, 6, 8 on that oxygen. But then my carbon only has 6. So we'll do the same thing on the other side. Steal a lone pair. Make a double bond over here as well. And that is our Lewis structure for carbon dioxide. Okay, guys, that's going to be the end of part 1 of this video. So that's what you should watch on like the first day. And then part 2, we're going to go over some kind of weird things with Lewis structures. So feel free to email if you have any questions, and we'll happily answer and help you. All right, bye, guys.